So today we're going to learn how to graph the reciprocal functions cosecant and secant. If you look off to the right, I've got a little note for you. What we're actually going to do is graph the sine or cosine function and then find the reciprocal at a couple of points until we get an idea of what our new graph looks like. Cosecant is the reciprocal of sine, so we're going to start by graphing the sine function. So sine has an amplitude of 1, so we're going to have -1 to 1. And sine has a period of 2 pi. Remember, we were looking at this quarter rotation, so we have pi over 2, pi, and 3 pi over 2 for the markers on our x-axis, and of course the negatives as well. When we graph our sine function, we start at the intercept. Sine then goes up to the maximum, back to an intercept, minimum, back to an intercept off to the right, and off to the left it goes down to the minimum, back up to the intercept, maximum, intercept. So if you think about taking the reciprocal of each of these points, the first thing that you should notice is that every time the sine function is 0, the cosecant function will be undefined. So we're going to draw in our vertical asymptotes everywhere the sine is 0 at all of those intercepts. And then we're going to start with the obvious reciprocals. Where the sine function is equal to 1, the reciprocal is 1. Where the sine function is -1, the reciprocal will be -1. So all of those max and min values are the same on the cosecant as they are on the sine function. And then you can think about just picking a couple of points in between to get an idea. So if we took the reciprocal of this point right here, the y value is about 1/2. The reciprocal of that is 2. So I'm going to rescale my y-axis. And then plot that reciprocal. And same thing over here, our y value is about 1/2, so the reciprocal of that would be 2 as well. What happens is that the cosecant looks like a whole bunch of parabolas. And then between the next asymptotes, same thing here-ish, the y value is about -1/2, so when we take the reciprocal of that, we get -2. Same thing over here, so that flips, we've got another parabola here. Unlike the quadratic parabolas we see, these have asymptotes that they go between, so it almost looks like they're going straight up or straight down. So again, just find a couple of points where it looks like the graph is about 1/2 or -1/2. Flip those to 2 and get your parabolas sketched. And one more off to the left. Alright, so let's take a look at domain and range for the cosecant function. Domain, as you can see, we've got all of those vertical asymptotes over and over. The asymptotes occur at multiples of pi, 0, pi, 2 pi, 3 pi, -2 pi, -3 pi. So the domain is that x cannot equal any multiple of pi. And the way we represent that is by saying x cannot equal pi times n, where n is an integer. The range, notice the cosecant function does not have any y values where the sine function does. The sine waves between -1 and 1, but for the cosecant, the parabolas that open up have a minimum value of 1, and the parabolas that open down have a maximum value of -1. So our range is y is greater than or equal to 1, and y is less than or equal to -1. So if you remember set notation, the other way we could represent this would be from -infinity to -1, including -1, because it is defined there, union, meaning also or and, 1 to positive infinity. Remember, infinity is a parenthesis because it's not an actual number. For the vertical asymptotes, it's very similar to the domain. All of those vertical asymptotes occur at multiples of pi. And then the period of the function, if you look for one parabola opening up and one parabola opening down, the period of the function is still 2 pi. You can't look at just a parabola opening up or just a parabola opening down. All this information is organized for you on your vocab sheet as well.